Now let's move to part 2, the long questions. The first question is about evaluate the integrals below. Remember that when you see the integrals, actually we have two types of integrals. The first one is definite integral, which means we have upper bound and lower bound. So we write like this. Okay, so another one is indefinite integral, which means you don't have upper bound and lower bound. Remember that when you say there exist A and B, which means this thing is equal to a number. And this number is actually the area under the function fx on the interval a to b. And if there is an indefinite integral, it should be a function plus capital C, and C is represents any constant. Okay, if you compute if you get a function, then you can do differentiation to get back the fx. Okay, so let me see the part A. You can see here we have lower bound is 0 and upper bound is 1, which means the answer should be a number. Okay, and it represents the function, this function, the area under this function between 0 to 1. And you can easily say that we have this part. So we need to use the substitution to solve this question. By substitution, we assume we let u is equal to x squared plus c plus 1. Okay, so we get du over dx is equal to 2x, and du is equal to 2x multiplied with dx, which means we can substitute du into dx. Remember that here we have two boundaries, and we need to substitute boundaries in under du. So we let x is equal to 0 and x is equal to 1. We get u is equal to 1 and u is equal to 2. Okay, so for x, we can also get we can rewrite this into from integral from 0 to 1 x square root of x squared plus 1 dx. This is equal to, okay, let me write one more step, times 2x dx. And why I write 2x here? Because we know that du is equal to 2x times dx. So we want to change this part into du. But we multiply 2 here, which means we need to multiply 1 over 2 before the integral. Okay, so it is equal to 1 over 2. From now it's from not from 0 to 1, it's from 1 to 2, because we use u from 1 to 2, and inside becomes to the square root of u, because x squared plus 1 is equal to u, and multiply with 2x dx, we change into du. Okay, so now you can see the integration becomes more easier, because we just need to integral u to the power of 1 over 2. This should be 1 over 2 plus 1 is 3 over 2, and multiply with 2 over 3. We substitute 2 and 1 into the function, so it's minus 2. So we get the answer. This is our final answer. You can also write like 2 times square root of 2 minus 1 over 3. Okay. Now we continue to do part B. Okay, you can say part B, we don't have the upper bound and lower bound, which means this is indefinite integral. So we need to get a function plus capital C, any constant. Okay, so how can we do this? You can see here we have cosine and sine. So it's better for us to do similarly in part A by substitution. We net u is equal to sine x, because here sine x has square. Okay, it's very difficult for us to directly compute this part, so we try to change this part into something easier. We let u is equal to sine x, so we have du over dx should be cosine x, so du is equal to cosine x dx. Okay, now you can see here we have cosine x dx, so this part we can directly change into du. Okay, so let me rewrite the integral of cosine x divided by 1 plus sine x squared dx is equal to, we can write one more step, 1 over 1 plus sine x squared times cosine x dx. I just want to show that we can use this part cosine x dx change into du. So this become to 1 over 1 plus u squared du. Okay, this is actually the integral for this part is actually equal to arc tangent u plus capital C by formula. Okay. Remember that when you use substitution, you need to rewrite what you substitute in the original type. Okay, so we net u is equal to sine x. We need to resubstitute to get a function about x. So it's arctangent sine x plus c. This is our answer. Okay. So for last part of this question, you can see now we have 0, 3 as lower bound and upper bound. So this is definite integral. So which means the answer should be a number, and this number is actually the area under fx on the interval 0 to 3. But you can see here we have a absolute value. Okay, so for absolute value, which means if we have a function fx, we add absolute value. The graph, for instance, if fx is like this, And if we add absolute value, all the parts below the x-axis will become to the symmetric to x-axis, which means all the parts of the function will become to positive. Okay. So to analyze this question, we firstly let x squared minus x minus 2 is equal to 0. Why? Because we want to figure out the graph for this function. Okay. And we get the point of intersection with x-axis should be -1 and +2, because we can write this equation into x minus 2 multiplied with x plus 1 is equal to 0. So x1 is equal to -1, x2 is equal to +2. Okay, which means this function is actually the quadratic function. So the graph should like this. Okay, this is x squared minus x minus 2. Here is 2, and here is -1. But we need to figure out the absolute value of this function. So this graph should be, we need to consider since absolute value is always non-negative, so we need to put this part, which means this for this interval between -1 and 2, this is under x-axis, so it's negative. Okay, so we need to make this part positive. The way to make this part be positive is to reflect this into the part above x-axis. Okay, so now the function becomes to this. Okay, this is absolute value function. This is -1 and +2. So we need to find the integral between 0 and 3. Okay, so where is 0? 0 is here, and 3 is here. So we need to find this area, right? Now you can easily say that from 0 to 3, the integral of this absolute value function, this is equal to this part, the first part, plus the second part. Okay, and which means we can rewrite the integral into the first function. The first function is from 0 to 2. And what's a formula for this function? This is actually the negative x squared minus x minus 2. Okay, this is actually the negative. So we write negative x squared minus x minus 2 dx plus the second part area from 2 to 3. This function is actually the x squared minus x minus 2 dx. And we need to compute this 2. So this is then we compute this. This is minus x cubic multiplied with 1/3 plus 1/2 times x squared plus 2x and 2, 0 plus. Okay, similarly we can get the integration for these two functions. Sorry, here should be 3, 2 to 3. Okay. And after we compute, we substitute the value into these two functions. and we can compute, this should be 31/6. This is problem 60. We move to next question. Okay, next question. You can say, suppose you are pumping air into a spherical hot air balloon. So we get, this is a spherical hot air balloon, which means we need to use the formula of a sphere. So the volume for a sphere, this is V, capital V, represents volume. V is equal to 4/3 pi r to the power of 3. Okay, and you pump at a constant rate of. Okay, remember that. If you say words like a constant rate of, what does this mean? This is actually means the rate of. If you say the rate of, it will relate to derivative. But you need to figure out which two random variables, the derivative of two random variables. You need to figure out. This is based on the unit. This is this unit is for volume, you can say, because this is a cubic, and per second, which means this is time taken. So you need to translate this sentence into a more math formula. This tells us we have dv over dt. dv over dt is actually the constant rate of change of volume over time taken. Okay. Why we can deduce this is capital V and this is T is based on the unit, because this unit is centimeter cube per second. So this is V and the second is T. This tells us dV over dt is 2000. And it asks when a radius of balloon is 3 meters. So we have R is 3. How fast is the surface area of a balloon changing? Okay, how fast? What does it mean? So this also means that what is the rate of change? Okay, so how fast? This actually equivalent to what is rate of change for surface area. Okay, so which means you need to figure out the derivative of d. We write capital A to represent surface area over dt. So you need to write. You need to figure out the dA over dt at r is equal to 3 meters. Oh, remember, here is 3 meters. So, but we have 30 meters. So it's better for you to transform into r radius is equal to 300 centimeters. So when r is equal to 300 centimeters, what is dA over dt? We need to figure out this. So for this part, which means we translate these sentences into math formula. We have a volume formula, and we know the derivative of dV over dt, and we know r, and we need to find dA over dt. Now how can we do this? Okay, so we want to figure out dA over dt. How can we use V or some other things to get this? The formula is that we can write like dA over dv multiplies dv over dt. Okay, now you can see we already know dv over dt. So how can we compute dA over dv? Okay, if you look at v is equal to 4 over 3 pi r cubic, which means v is actually the function of r. So we can write one more step. We can write dA over dr multiplied with dv over dr and multiply with here should be dr over dv and dv over dt. So which means we can find this because we also have the surface area formula is surface area for a sphere is 3 pi r squared. Okay, and we need to figure out this. This is actually you can take 1 over dv over dr to get this part, and this part we know the value. So this is our idea to solve this question. Since we have a is equal to 4 pi r squared, so we have dA over dr is equal to 8 pi r, and we have v is equal to 4 over 3 pi r to the power of 3. We have dv over dr is equal to 4 pi r squared. Okay, this is 4 pi r squared. So the dr over dv is 1 over 4 pi r squared. Then we add them together to get dA over dt is equal to dA over dr multiplied with dr over dv and dv over dt. So for dA over dr, this is 8 pi r times dr over dv. This is 1 over 4 pi r squared, 1 over 4 pi r squared, and multiply 2000 because we already know that the rate of change of volume over time is 2000. So here is 2000, and we can cancel pi r out, and 8, this should be 2. So we have, after simplify this equation, it should be dA over dt should be 4000 over r. And now you net at r is equal to 300, you get dA over dt is equal to 4000 over 300, so it's 40 over 3. And remember to write the unit, 30 meters squared per second. This is our answer. I think this question is very similar to some web work questions. If you can look back your web work questions, you can try to do some question like you use this formula, or you use a formula like like dz over dx is equal to dz over dy times dy over dx, like this. Okay, this is the test point for this question. Now we move to the next one. Problem 18. Consider the following functions. fx is equal to ln x squared minus 2x plus 10. For the part A, you need to figure out the first derivative of this function and the second derivative. Okay, so we can directly compute. Actually, we need to use the chain rule for this question because you can see this is actually the composite function, which has the inner function x squared minus 2x plus 10 and the outer function ln x. Okay, and remember that the derivative of ln x is 1 over x. This is very important. You need to remember this. Well, you need also remember that for 1 over x, the integral is equal to ln absolute value of x plus capital C. So you need to remember these two formulas. I think is quite important. Okay, because especially for this one, some students may think this is x to the power of -1. Okay, you cannot directly use the rules to integrate this because this is x to the power of -1. Okay, so this kind of function is very special. It's equal to ln absolute value of x. Okay. We come back to our question, and we have fx. So the first derivative should be, this is ln, and we know that the derivative of ln x is 1 over x. So we write 1 over, write down the inner function. Okay, the inner function is x squared minus 2x plus 10. So it's x squared minus 2x plus 10. Multiply with the derivative of inner function, which means we need to figure out the derivative of the inner function x squared minus 2x plus 10. This is equal to 2x minus 2. Okay, so we have 2x over x squared minus 2x plus 10. This is the first derivative. Okay, then we need to compute the second derivative. So for the second derivative, you just need to consider the function for the first derivative and try to do differentiation for this function. So now, how can we do this? This is fx over gx. So the derivative, we need to use the quotient rule. Okay, the quotient rule. Well, the quotient rule, the formula. Let me write down the formula. The formula is 1 over fx over gx. The derivative is f derivative multiply gx minus fx multiplied with gx derivative over the square of gx. So we can use this formula and figure out the second derivative. This should be the denominator is the square of x squared minus 2x plus 10. And for the numerator, we firstly differentiate the f, which means the function above. So this is 2 multiply gx is x squared minus 2x plus 10 minus, remember this is minus. Okay, it's very easy to make mistakes because this sign is different from our power rule. Okay, for our power rule this is plus, and for the quotient rule this is minus. Okay, so fx, we write down fx, this is 2x minus 2, and multiply with the derivative of gx. Gx is here, so the derivative should be 2x minus 2. We can simplify this. The numerator is minus 2 times x squared minus 2x minus 8 over x squared minus 2x plus 10 square. Okay, now we finish the part A. We already compute the first derivative and the second derivative. So for part B, we need to solve each of the following inequalities. Okay, so first is interval for the function that is positive, and the second part is figure out the interval for first derivative that is positive, and second one is for second derivative. Okay, so for the first part, we need to let fx is greater than 0. So we have x squared minus 2x plus 10 greater than 0. So this is actually, well, if you notice that, we can write x squared minus 2x plus 1 plus 9. Why? Because you will get x minus 1 squared plus 9. You can see here is a square. We know that the square is always like absolute value. It's always non-negative. Okay, so it's greater or equal to 0, and we have plus 9. Actually, this equation is greater or equal to 9, and so it's definitely greater than 0. Okay, so you write that. You write so for all x belongs to R. Is true. It's true for fx greater than 0. Okay, for the second part, the first derivative should greater than 0. So we from part A we know that we compute this part. We already compute this part, which means 2x minus 2 over x squared minus 2x plus 10 greater than 0. And remember that 2x over minus 2, and the denominator we can similarly write 1x minus 1 squared plus 9 greater than 0. And you can see that the denominator is always positive, right? It's always greater or equal to 9. So the only things we need to consider is about the numerator. Numerator is 2x plus 2, so we must let the 2x plus minus 2 greater than 0. So we get x should greater than 1. Okay, so we write for any x greater than 1, we have the first derivative is always positive. Okay, so the last part for B is the second derivative. Second derivative greater than 0. So we already compute the formula, and you need to consider that the denominator is already a square, which means the denominator is always greater or equal to 0. So we just need to consider the numerator. The numerator should be positive. So the numerator is minus 2 x squared minus 2x minus 8. This should be greater than 0, and you can get this means x minus 4 and x plus 2 is smaller than 0, because this is minus. When we divide minus 2 on both sides, the sign will change. Okay, so if you draw a graph, this is 4, this is minus 2, this is x minus 2 times x plus 2, x minus 4 times x plus 2. Okay, you can say for which interval is smaller than 0, it's actually this interval, the between minus 2 to 4. So you write for any x greater than minus 2, smaller than 4, we have the second derivative is greater than 0. Okay, this is part B. We move to part C. Find all critical points and the inflection, which means we need to figure out the number that first derivative is equal to 0 to find the critical point, and we net the second derivative is equal to 0 to find the point of intersection. Okay, so for part C, we let the first derivative is equal to 0. Then we have the first derivative is 2x minus 2 over x squared minus 2x plus 10 is equal to 0. So, which means the numerator should be equal to 0. So 2x minus 2 is equal to 0 and x is equal to 1. Okay, x is equal to 1. And we need to deduce, this is a local, we just have one critical point, but is this local minimum or maximum? We need to use the second derivative, let x is equal to 1 and put 1 into the second derivative. And we can compute that for second derivative, this is greater than 0. So we have the local, actually there is a global minimum because we just have one local minimum. This one should be the global minimum point is 1 and long line, because you put x is equal to 1 into the function, you will get the value of y. Okay, this is a critical point, and for the point of intersection, we let the second derivative is equal to 0. Then we have the second derivative is minus 2x squared minus 2x minus 8 over x squared minus 2x plus 10 squared is equal to 0. So we get x minus 4 multiplied with x plus 2 is equal to 0. So we have x is equal to minus 2 or 4. X is equal to 4. Okay, so now you need to consider that the limit. Okay, the limit. You need to consider these 2 points. If you substitute 4 from the left-hand side, which means 4 negative, this is actually, if you add, like you try to substitute some value like 3.9 or 3 that's smaller than 4 into this function, and you can say this is greater than 0. And this one is smaller than 0. Similarly, you can get for negative 2, this is greater than 0. So this shows us these are the 2 points of inflection. Okay, 2 points of inflections of the function, and we substitute x is equal to minus 2 and 4 into the function to get the values of y. So we get the points of inflection. Points of inflection are 4 ln 18 and okay, this is part C. And we can see the part D. The last part for this question is to sketch the curve of y is equal to fx. And we know that we just have one local minimum, and that one is ln 9. This shows that for this function, okay, we just have a one local minimum, and we have 2 point of inflection. So the graph looks like oh sorry, this is ln 18. Okay, so the graph is like here is one ln 9. This is a global minimum point, and we have 2 point of inflection. One is -2 ln 18, another is 4 ln 18. Okay, so it should be like this. And after the point of inflection, okay, this is y is equal to fx, x, y. When you sketch a graph, you need to add the points that you calculated before, like the points of inflection or the minimum or maximum points, and show these points, show the position of this point on the graph. Okay, and try to find a best fit line, best fit curve to draw this graph. Okay, so we move to problem 19. It shows a graph, which means for the upper right angle triangle, we fold it into the bottom side. Okay, so for part A, we need to show that y is equal to a function. It's a square root of x to the power of 3 over x minus 10. Okay, so how can we show this? Before we do this, let me analyze this question on this graph. If we write this line, this perpendicular line, and we name this point, this is A, B, C, D, and E. Well, you can say actually this triangle is equivalent to this, because this one folded to form this one, so they are equal, which means if this length, well, here we use D prime because this point is corresponding to this point. Okay, so if D prime is equal to x, BD, the length of BD is also equal to x. And we know that this side is 20. So the CD prime, this length is also 20. And here is x, so we have BC. We can easily say BC is 20 minus x. And you notice that, oh well, we have this small right angle triangle. In the triangle BCD, we have the angle C is 19 degree, and BD is equal to x, and BC is equal to 20 minus x. So we have CD is equal to the square root of BD square plus BC square, which is equal to the square root of x squared minus 20 minus x squared. We can simplify this by expanding the bracket square. Okay, so this is equal to 40x minus 400. which means we already know the length of CD. This is 40x minus 400. Okay, now you notice that, well, we have AE is actually equal to 20, and how can we find Y? Y is in this triangle, and the square root of AD plus square root, the square of AD plus square of BD is equal to the square of Y. Okay, is equal to the square of Y. But now we know the BD is equal to X, and the final thing for us is to compute AD, the length of AD. Okay, we know that, so for AD, how can we compute this? We already know AE, the length of AE, and we need to compute the length of DE. But what is the length of DE? Well, you can say DE is equal to EC minus DC, right? Because we have EC minus DC is equal to DE, so we write down as DE is equal to EC minus DC. But you can say that, well, what is EC? EC minus DC. Okay, so EC is actually AD, right? Here is AD. EC is equal to AD because this is a rectangle. And EC is equal to AD prime. It's equal to AD prime because of this is a rectangle. And we know that AD prime is equal to AD because D is corresponding to D prime. These 2 points, they are folded. And so we can write EC is equal to AD prime minus DC, which is equal to AD minus DC. So we can rewrite ED in terms of AD minus DC, and we already know the formula for DC. Okay, and we use the Pythagorean theorem. We know that in the triangle AED, we have the formula that AD square is equal to AE square plus ED square. And we know ED can be rewritten as AD minus DC, right? So we get AD square is equal to AE square plus D square. So we can write AD minus DC square. And we simplify this. This is AD square is equal to AE square plus AD square minus 2AD times DC plus DC square. And you can see, oh, we can cancel AD out. And we know that what is DC? DC is equal to CD. They are the same line, and CD is square root of 40x minus 400. So we have and we also know that what is AE? What is AE? AE is 20, right? AE is 20. In this graph, AE is 20. So we have we substitute the value of AE is 20, so it's 400 plus or minus 2 times AD. 2 times AD. We don't know AD, and we know DC. DC is square root of 40x minus 400 plus DC square. DC square is 40x minus 400. Okay, so we get AD. The expression for AD is 20x. We can simplify the above equation and we get this identity. AD is equal to 20x over square root of 40x minus 40. and in the triangle, the final step in the triangle ABD. ABD, we already know AD and we know BD, so we know Y. Okay, so in triangle ABD, we know the square root of AB is equal to the square of AB is equal to square of AD plus square of BD. So we can have y squared is equal to AD squared, so it's plus BD squared. We know BD is x squared. Okay, then after simplify, we get y is equal to square root of x to the power of 3 over x minus 10. Okay, here is the answer. So we prove this. We prove the part A. And how about part B? Part B says that using part A, so we need to use this result. Actually, even if you didn't prove this, you can still continue to do part B in your exam. Okay, so which means if the first part or the first few part is about to show the function in a specific expression, even if you didn't prove this, you can continue to use the result to do the rest of questions. Okay, so using part A or otherwise, find the minimum value of y. Okay, find the minimum value of y. So, which means we need to find extreme value. We need to figure out the first derivative and let the first derivative is equal to 0. Okay, and then we compute the value. Okay, so we write. Okay, so we write part B. Since we have y is equal to square root, now I change square root into this to. So write it in this because if we write the bracket to the power of 1 over 2, it's easier for us to compute the derivative by using chain rule. Okay, so the derivative should be the dy over dx should be 1 over 2 times to the power of minus 1 over 2 multiply with. Okay, here we need to do the using quotient rule to compute the derivative of inner function. So this is x minus 10 squared and 3x squared, x minus 10 minus x cubic times 1. Okay, after simplify, we will get the first derivative for this function is x minus 15 over x times x minus 10 to the power of 1 over 3. So we assume dy over dx is equal to 0. We get x minus 15 is equal to 0. We get x is equal to 15. Okay, we get x is equal to 15. Okay, but we need to check if this is a minimum value. There are two methods. The first one is compute the second derivative and put x is equal to 15. Another one, the method, but you can say, well, this function is quite complex, and if we continue to directly compute the second derivative, it will be quite difficult. But we can try to substitute the value around 15 into the function. Like we can have x is equal to 15, and we can have the x smaller than 15, x greater than 15. Okay, so the derivative, the first derivative. Okay, we will get this is minus, this is positive. Okay, this is actually shows that is a minimal point. Well, this method is better when you see the first derivative has a very sophisticated function and you don't want to compute the second derivative. Okay, so this is a minimal point, and we let x is equal to 15 and compute y, and y is equal to the square root of x cubic over x minus 10, which is equal to the square root of 15 to the power of 3 over 15 minus 10. This is 15 times square root of 3. Okay, this is a minimum value of y. This is a problem 19. And now we move to the last question, problem 20. Okay, the problem 20 shows that tells us let f(x) be a continuous function with the second derivative of f(x) greater than 0 for all values of x, which means the second derivative is always positive. Okay, so for each statement, determine whether it is true or not. Give a brief reasons. Okay, so for part A, f has at most one critical point. Well, when you say a critical point, you need to consider about the first derivative, because you know that the critical point is equal to 0. Then we can compute the if we want to compute the critical point, we need to compute the first derivative and let the first derivative is equal to 0. So the question is about the critical point. You need to consider the first derivative. What can we deduce about first derivative when we have the second derivative is always greater than 0? Well, if for any x belongs to R, we have the second derivative is greater than 0, then we know. Actually, the second derivative is actually the value of slope of tangent line for the first derivative, which means we can deduce that the first derivative is always increasing. So it's always increasing. If a function is always increasing, it just has one possible for this function to have critical point. That one is it has a minimal point, and you can say here is greater than 0. Actually, this function is strictly increasing. Okay, so which means only one possible for the first derivative to have minimum point. So for a function that is strictly increasing, there is no probability for this function to be to have point of intersection or to have the maximum point. It just has a minimum point, because the strictly increasing means it cannot be like stationary, or it's always increasing, and so there is no maximum point, and it just has a minimum point. So the first statement is true. It's true. Okay, at most one critical point. Then we consider the part B. Okay, for part B, we have at x is equal to 0, the function value is 0. X is equal to 3, the function value is equal to 3. Then we have the integration of fx between 0 and 3 is greater than 9 over 2. Okay, So we can sketch a simple graph to see. Here is 0, here is 3. So here is 0, 0, and here is a point 3, 3. Well, what is 9/2? 9/2 is actually the area, the triangle area with the length 3 and 3. You can say 1/2 times 3 times 3 is equal to 9/2. Okay, and how about this side? This area we recall the problem 16. We have lower boundary and upper bound, so this should be a number, and it shows the area under fx between 0 and 3. Well, we have another condition, is that for all x belongs to R, we have the second derivative always positive. The second derivative is always positive. This means y is equal to fx is a concave upwards function. It's a concave upwards function. So I use a right line. So for function, it's like this, the concave and upwards. And you can say if it's concave, so the area under the function between 0 and 3 is always smaller than the area of triangle. Okay, so we have the area under fx between 0 and 3 is always smaller than the area of the triangle so we have the integration smaller than 1/2 times 3 times 3 is equal to 9/2. Okay, but the statement says the integral should be greater than the area of triangle, so this is false. So the statement is false. Okay, so for the last part C, taking the same assumption, which means we have f0 is 0 and f3 is 3. Okay, and it's possible. The statement says it's possible for the first derivative at x is equal to 3 is 1/2. Okay, so we can use the mean value theory, and the mean value theory tells us that for there exists some C belongs to the open interval 0 to 3, and such that the first derivative at x is equal to c is equal to f3 minus f0 over 3 minus 0. We know that f3 is 3 by previous part. This is equal to 1, which means for some c greater than 0, smaller than 3, we have the first derivative should be 1. And we know that the second derivative is always positive, so the first derivative is always increasing. it's always increasing. Well, if the between x between 0 and 3 we have some constant c at this point, the derivative is equal to 1, which means that after this point for c plus any number, okay, c plus any number, the for instance we have a is greater than c, and then the derivative of a at this point x is equal to a, the first derivative is always greater than 1 because the first derivative is always increasing. Okay, well, we have x is equal to 3, which means at this point the first derivative f prime 3 is always greater than 1, should be greater than 1 because the first derivative should be always increasing. Okay, so we have the at x is equal to 3, the first derivative is always greater than 1. But the statement says it's possible to make it equal to 1 over 2. This is greater than 1 over 2, so this is not possible. It's false. Okay, so the answer is true, false, false for last problem.